Okay, so since we're talking about limits, let's take a look at just a really simple function. Let's say I've got um, the function x squared, and so the first thing I want to do is just get a sense of what a limit is. So here I've got a function, x squared, just your simple parabola. And so you have a question. You want to know what's the limit as x approaches to 2 of your function. In other words, this guy right here, of course, is x squared. So what this is saying, this is asking you a question. It's saying, as x approaches 2, so here let's mark these. Let's say this is 2. What you want to know is what y value, or another way of thinking about it, since y is generic, what value or what height or what y value is your function approaching. So, I mean, the answer seems obvious, because for example, right here, if you find the value of the function at 2, well, you know that that's equal to plugging in 2 into your function x squared, which would just give you simply 4. So the difference between that and what the limit is the limit is saying, okay, if you are walking along on your function, say imagine you're a little person, and you're walking along the function, and as what this guy is asking is, as x approaches 2, so as you get closer and closer to x equals to 2, what's the y value that you're also approaching? And the answer to that happens to be, in this case, that it's exactly the same. The answer is 4. That means that I'm approaching that value, that y value 4. Okay, sounds simple enough. But now, what if, for example, I have the same function, so the same exact function, except that this time, I'm going to call it g of x. Let's say g of x, delete this a little bit. Let's say g of x is x squared when x is not equal to 0. And let's say that it equals to 4 when x is equal to 0. Okay, so here if I graph this guy, it's going to be a parabola, except that at x equals to 0, it's not going to be a parabola. There's going to be a hole there. And let me actually change the color. I don't like this color very much. Okay. Okay, so everywhere except for x equals to 0, it equals to x squared. Same as this function over here. But at x equals to 0, my function is equal to the number 4. Okay, so this is what this function looks like. Now, this time though, notice that if I ask what is f of 0, sorry, not f of 0, g of 0, if I ask what's g of 0, this time you would say that that function is equal to 4, because at x equals to 0, that function's equal to 4. Okay, but now if I ask what's the limit as x approaches 0 of this function g of x, this time it's a little bit different, because if you think of it, if you're right here and you're walking towards 0, you're just walking along, happy-go-lucky, you're not approaching 4, you're approaching, getting closer and closer to. Now when you say closer and closer to, you mean that as close as humanly possible, or theoretically possible, without actually reaching the number 0. So the place where you're going, no matter if you're coming from the right side or the left side, you're going towards this point right here, which is 0. So that's the difference in the two questions. The limit is asking where are you going, and this guy right here, evaluating a function at a point, is asking you where are you at that instant. Okay, now let's take a look at an example here, another example. First, let's talk about real quick about what one-sided limits. So when I write, for example, the limit as x approaches 3, and then I put a little negative symbol up on the top of 3, what that means is I'm asking, as I approach 3, as x approaches 3 from the negative direction, or in other words, from the left side. So as I approach 3 from the left side, where's my function going? And so then if you imagine, you're on the left side of 3, so 3 is right here, so just put yourself on the left side of that and walk towards x equals 3. Ask yourself, where are you going? Well, you're going to the y value. Again, that's the one you're looking at. You're going towards 5. Okay. And then what about if I'm coming, let's say I'm approaching 3 from the right. Again, now this time, the positive symbol, this is approaching from the positive direction, so that would be from the right-hand side. And so as you're approaching from the right, where's your function going? So this time you're standing on the right side of x equals 3. And you can be anywhere on the right side. You can be, even over here. You can then jump down right here, like Super Mario Brothers. Anyways, and so then as you get closer and closer to x equals 3, you're approaching a y value of, this time, 8. Okay. So then what we say, so these are the one-sided limits. So then what you can say is that the limit as x approaches 3 of your function. So this is really, really important. So when we say that to find the limit as x approaches 3 without a sign on top, that means that it has to be the same both from the right and from the left for this limit to exist. So because these limits are different, then we say that the limit does not exist. So this gives us an important theorem that for the limit as x approaches a to exist, what we just said has to be true. In other words, the limit as x approaches a from the left has to equal to the limit as x approaches a from the right. Okay, so then what that means is that, for example, if I'm approaching 6 from the left, notice that as I'm approaching 6 from the left, my function's going towards 1. So as x approaches 6, f of x approaches 1. If I'm coming from the left. But then as x approaches 6 from the right, notice that this time f of x is approaching 9. So again, the limit as x approaches 6 of your function does not exist. Okay, and then let's take a look at the other place where we've got some funny business. Let me erase a little bit of this stuff. If you take a look at the limit as x approaches 8 from the left, you'll notice that it keeps going, as you get closer and closer to 8, it keeps going down without stopping. And so what we say is this guy is going towards negative infinity. And then the limit as x approaches 8 from the right is also equal to negative infinity. And notice that, so just to let you guys know, that doesn't mean that the limit actually exists. It doesn't really exist because it's not really a number, but at least you know that it's going in the infinite direction, the negative infinity direction, from both the left side and the right side. And so then you would say that the limit as x approaches 8 of your function is equal to negative infinity.